Today, we're going to be talking about system of systems resilience.
The world is more connected than ever. The small states like Singapore, like Switzerland, are now hubs of innovation, hubs of growth, hubs of capital development, business. Both states built their infrastructure, they built up their reputation over time.
Urban systems, such as our energy grids, our water networks, and our transportation systems, they are highly interconnected.
The question is, how can we make them more resilient? Our cities are complex entities. Resilience of this system of systems to a shock is not a simple thing. It has to do with adaptation, it has to do with recovery, it has to do with continuing after this disruption. Our Future Resilient Systems program is about understanding this complex system of systems. We are here to look for their vulnerabilities, to investigate how individual systems recover, adapts, and becomes better after a disruption.
By analyzing and understanding these interdependencies, you can then design and look for solutions that not only addresses the immediate needs in terms of risk reduction, but also be able to plan for longer-term sustainability and resiliency of these systems.
Failure in one cascades through all of them. It is impossible to isolate these systems. And we often measure the impact of these cascading failures through economic disruption. It is the loss of commerce, it is the loss of trade.
Our water systems, our transportation systems, and also now with the EV adoption and the solar voltaic generation, all this will introduce uncertainties and potential disruptions or stress points on the energy grid. Our energy grid are highly interconnected. Using our systems of push modeling, you can then see how do these disruptions play out across not only the energy grid, but also how does it propagate towards the transportation or the water as well as the other infrastructural systems. So on a larger spatial scale, sectorial dependencies within a region or within a country can create dependencies that can magnify economic vulnerabilities. So for taking an example, manufacturing and utility sectors are obviously highly interconnected, but they're also interconnected with the transport sector, with the service sector. Therefore, when there's a disruption in manufacturing, not only utilities might be affected, but transportation, financial sector, services sector may also be affected.
Urban infrastructure is a very good example of how one of the systems in a city can affect all others. Very often these failures are quite localized, like the MRT failures that may happen due to station blackout or perhaps even some damage. Engineers and planners would like to develop targeted strategies to first mitigate the disruptions in infrastructure systems and other systems that form a city. But also they want to develop plans and ways of repairing and recovering after a disaster. FRS developed a set of tools to analyze the effect of urban disruptions and then also to model recovery. These tools span a wide range of sectors. Some are quite specialized to particular infrastructure or to the economy or to a particular trade or transportation system. But ResQ-iOS is a tool that tries to combine all of these systems into one. The underlying feature of this tool is optimization. We want to be able to not only look at how systems recover, but optimize the distribution of limited resources that these systems have, and also optimize the limited recovery resources that the city may have. Together, such optimization is able to deliver a plan of recovery after a disruption.
So resilience must be a policy priority. Urban planning must have to take into account system of systems tools and methods in terms of how they be able to manage resilience in cities. We should also consider regional collaboration when we look at resiliency of city-states like Singapore and small countries like Switzerland. These economies are highly interconnected with, trading, banking-wise, with the rest of the world. And so a shock in any of these systems can potentially propagate across countries as well.
But what is coming in next is artificial intelligence. It is going to create a situation where the operators of systems are working together with agents that are based on some form of artificial intelligence, who are probably better suited to quickly detect the flaws, integrate the sensor data, and help the operator realize what is going on, gain situational awareness, and also help the operators gain an upper hand over the disruption. We need holistic solutions, not only AI-based, but also involve people of all kinds and walks of life, involve policymakers, economists, nurses, teachers, everyone, to contribute to the well-being of our city. That includes sustainability, but also includes resilience, ability to spring back after a disaster.
The challenges of tomorrow demand action today. We must incorporate systems of systems methodology into our planning of our cities.
We hope that the students, the researchers in our program, are going to follow through and become engineers and planners and policymakers in future cities, that they will be very effective in not only providing new technologies, but also shaping policies to make the future cities more resilient and the future societies more resistant to disasters.
This will then enable policymakers to understand what is needed to be done, not only to design for short-term solutions, but also looking for long-term decisions in terms of making the systems more stable.